Quarantine Science Lab 5B. I would like you guys to tear up the aluminum and make it into little balls while I'm explaining what we're going to do. We're going to create yeah, that's a good one. Leave it there. Small enough so that they fit in the mouth of your beaker here, your Erlenmeyer flask. We're going to create a sodium hydroxide solution. That's a molecule that looks like this. Okay, it has a sodium atom and a hydroxide atom.
I have to be tied in the bowl?
No, not yet. Don't put them in there yet, but...
No, I mean the bowl.
Not too tight. Yeah, just small enough to fit into the flask. I think yours need to be a little bit smaller, Derek.
They're fine.
Okay. Now once that aluminum hits that sodium hydroxide atom, it's going to replace, let's pretend that this is now an aluminum atom. It's going to attach to three oxygens, and it's going to form a molecule that looks something like this, with a sodium attached to it. Then we're going to end up with something like this, a sodium aluminum oxide, something like that. And what's happened is that these three oxygens have lost their hydrogen. And so this hydrogen is liberated. And three new bonds have formed. When bonds form, they release a ton of energy in the form of heat in this case, and these hydrogens are going to bind together. They're going to create hydrogen gas. A little tighter, a little bit tighter, and it'll fit, okay? I'll help you, don't worry. These hydrogens are going to waft up into the air out of the flask, okay? And then what's going to happen? We're going to light them with a lighter, with a flame. And when they light, they're going to react with the oxygen in the atmosphere, and they're going to form, what's this?
Water.
Water. That's pretty impressive. Marie knows, and Derek knows what water molecules look like. All right, are you ready? Now we're going to put all that aluminum into your beakers, and then I'm going to have you guys step away, okay? Because now I'm going to start mixing a dangerous chemical. The sodium hydroxide. The sodium hydroxide molecule.
Not gonna come in here. You stinking.
Yeah, I'll help you with this. That little stinker. She's a little stinker.
Yeah,
all right, now he'll fit in there maybe.
That
Let's
woman
see.
is a stinker.
So the sodium hydroxide is dangerous because, look at this, it wants to tear a hydrogen away from whatever it touches, like your skin. Your skin's full of hydrogen atoms. It wants to tear away a hydrogen from your skin and bind to it, okay? So that's why the sodium hydroxide is a little bit dangerous. So I'm going to ask you guys to step over here and watch from the distance, okay? While I mix this up, all right? So now I'm going to create this sodium hydroxide solution. Make sure I'm using the right stuff. It's going to get real hot, but it's not going to get too hot just by mixing it. It's going to be a pretty strong solution though, so I am going to want to watch the temperature on this so it doesn't, well, it's not going to burn the table because it's not going to get any hotter than 212 or 100 degrees. Do you see vapor? Okay, it's getting a little bit warm, but it's not out of control hot. Okay, so it will get very hot when we mix it with other things. So if but it's not going to get hotter than boiling water. Now, before we start this, I'm going to light this alcohol lamp so that I can light a splint here. Okay, so I'm going to leave that here. There we go. Okay, you guys ready? I don't think this is terribly dangerous right there, as long as it doesn't roll anywhere. Now I'm going to show you how basic this solution is. It's a very strong base. Okay? It's litmus paper, it's pH test paper. It's okay, sweetie. So look how strong of a base that is. Okay? It's way over here between 12 and around 12, I think. Okay? I'm going to leave that right here. So now, when I pour this into your flasks that you created, it's going to start to generate hydrogen gas. That's this H2 molecule is going to come out the top, okay? See the reaction happening? Guys, come on over and look at the reaction up close. It's okay to look at it. Yeah. See the reaction happening? There's gas coming off. What you see is water vapor. Water particles in the air. You can't see steam, but you can see water particles in the air. What you don't see is hydrogen gas coming off. Stand back, please.
I see the steam, Elise.
Stand back, please. Look at that. Isn't that cool?
I just saw this. Sorry, I forgot.
Derek, go turn the fan on, please.
Oh, God.
All right. Isn't that cool? That's hydrogen gas burning. See the orange flame? That's one indicator that it's pure hydrogen burning. Okay? There's no blue or green. Yeah. If there were some green in there, or blue, we might wonder, is there some source of chloride or chlorine gas in there? And that might be dangerous. But this pure orange flame indicates that it's hydrogen.
What if you light the smoke?
The smoke is not really smoke, but water vapor. Do you understand?
I thought the fire would just go in and smoke, you know.
That's a different type of smoke. But that's a great question, Bud. When you burn wood or a wick of a candle, there's carbon atoms that are rising up with the water vapor. And when you light that, it is combustible because it has some carbon in there. But in this case, the smoke, look at that. That's very cool. Oh, it went out. Darn it. Just as I was about to light it again, it went out.
And the other one went out.
That's a cool effect, isn't it? So it looks like the reaction's about done, which is great. We didn't break anything.
Do you expect that?
No. You know. And yeah, nothing overheated, nothing caught fire, and so we did good. What do you think, Marie? Did you like that? Yeah? Was that a good experiment?
Yeah.
Baba? Yeah?
When the
Okay.
lights were off,
Thank you.
I wasn't afraid.
You weren't afraid? Say that again.
When the lights were off, I wasn't afraid.
Good for you. You're going to be a scientist one day.